Welcome to The Explainer. Today we're jumping headfirst into one of the most ambitious and frankly mind-bending ideas in all of modern physics, the mysterious framework known as M-theory.
All right, so to really get a grip on this, we've got to start with the core conflict, the deep crack in the very foundation of physics that M-theory was born to fix. And that really is the central question, right? For the better part of a century, physics has been running on two completely separate, wildly successful, and totally incompatible operating systems.
So on one side, you've got Einstein's general relativity. It's elegant, it's classical, it describes the big stuff: planets, galaxies, a smooth, predictable cosmos shaped by gravity. But then, on the other side, you have quantum mechanics, and it is just bizarre. It's all about probabilities and chaos at the tiniest scales. Now, they're both perfect in their own realms, but here's the kicker. When you try to use them together, say to describe what's happening inside a black hole, the math completely breaks down. It just spits out nonsense.
So yeah, this contradiction was a massive problem. But then, back in the 1980s, this beautifully strange new idea popped up that promised to finally stitch these two pictures of reality together.
The idea was, what if we replace all those different fundamental particles, electrons, quarks, photons, with just one single fundamental object, a tiny, vibrating string? So in this theory, everything we see in the universe, every single particle and every force, is just a different note being played by these little strings.
And this is where it gets really cool. This is the magic of the theory. It didn't just allow for a quantum theory of gravity, it demanded it. It turned out one of the string's natural vibrations had the exact properties of the graviton, the hypothetical particle that carries the force of gravity. Suddenly, for the first time ever, Einstein and quantum mechanics were speaking the same language.
But, of course, there was a catch. And it was a pretty big one. For the mathematics of string theory to actually work, to be consistent, it couldn't exist in our familiar three dimensions of space. It needed more.
So, where are they? Well, the idea is that they are compactified, which is just a fancy way of saying they're curled up incredibly small. The classic analogy is a garden hose. From way over here, it just looks like a one-dimensional line. But if you're an ant walking on it, there's this whole other dimension you can explore, the circle going around it. The extra dimensions in string theory are supposed to be like that, just curled up so tiny we could never, ever notice them.
Okay, so the bottom line is this. These early versions of string theory required a universe with a total of 10 space-time dimensions. That's 9 for space and 1 for time. But right when physicists thought they were finally closing in on that single, beautiful theory of everything, the picture got messy all over again. See, the problem was that the math didn't spit out just one version of string theory. By the early 90s, physicists had developed 5 different and seemingly totally independent string theories.
And each one of these was perfectly sound mathematically. But they all described slightly different universes. Different kinds of strings, different symmetries. Having 5 competing ultimate theories was, well, it was a huge letdown. It felt like they just traded one giant problem for 5 smaller ones.
But then, something amazing happened. By looking closer, physicists started finding these hidden connections, these secret passages almost, that linked these 5 different worlds. And that led to a massive breakthrough. The key concept that saved the day was something called duality. It's this super powerful idea where 2 theories that look completely different turn out to be describing the exact same physics. Think about it like this. Take a cylinder. If you look at it from the top, you see a circle. Look at it from the side, you see a rectangle. They seem like totally different shapes, right? But they're just 2 different views of the same object. Duality is pretty much the physics version of that.
And this had just incredible consequences. Physicists realized that what looked like one string theory with really strong, messy interactions was actually the exact same thing as a completely different string theory, where the interactions were weak and simple. So calculations that were impossible in one theory suddenly became a piece of cake in its dual version. It was a game changer. The 5 string theories weren't separate at all. They were all connected in this incredibly complex web of dualities.
So all these discoveries were setting the stage for a really pivotal moment. I mean, look at this timeline. The clues were piling up. Way back in '78, physicists had this old theory of supergravity that only worked in 11 dimensions. They kind of set it aside. Then, through the 80s and early 90s, you have these 5 string theories in 10 dimensions, which they now knew were all connected. It was all building to a climax, which happened in 1995.
So picture this, a string theory conference in 1995. A physicist named Edward Witten gets up to speak and just drops a bombshell. He stands up and proposes that these 5 theories weren't different theories at all. They were just 5 different perspectives on a single, much deeper, fundamental theory.
And this parent theory, it didn't live in 10 dimensions like its children. It lived in 11 space-time dimensions. Remember that old forgotten supergravity theory from the 70s? Turns out that was the key all along.
Witten called this new overarching framework M-theory. And the idea is that if you look at this one 11-dimensional theory under different mathematical conditions, kind of like looking at that cylinder from different angles, it just looks like one of the 5 distinct 10-dimensional string theories. They're all just shadows of a single, higher-dimensional reality. And get this, M-theory didn't just unify what they already had, it revealed that the universe's toolkit was way bigger than anyone had imagined. It turned out reality wasn't just made of these one-dimensional strings. It could also have higher-dimensional objects called branes, short for membranes. You could have 2D sheets, 3D blobs, you name it, all existing as fundamental pieces of nature.
So, Witten's proposal kicked off what's now called the second superstring revolution. But even though the idea was revolutionary, actually figuring out the full theory, well, that's proven to be a massive challenge that continues to this day.
So you might be wondering, what does the M in M-theory stand for? Witten himself was pretty playful about it. He suggested it could be for magic, mystery, or membrane, because of the new objects in the theory. He basically said we can decide what it stands for when we finally figure out what the theory actually is.
And this is a really important point. M-theory isn't a finished product with some neat set of equations you can write on a t-shirt. It's more like a map of a brand new continent. We know the coastlines and some of the big landmarks. Those are the 5-string theories and that 11D supergravity. But the huge interior, that's still completely uncharted territory.
And that leaves us with a pretty wild final thought. If this whole framework is right, it suggests that our entire, vast, 4-dimensional universe might just be a brain. Just a slice of reality floating inside a much larger, totally unseen 11-dimensional space. I mean, just think about that. We could be living on a membrane, completely unaware of the true cosmic ocean that's all around us.